Hey everyone, welcome back. We're diving into the world of AI agents today, something I know a lot of you are interested in. Now, you want to build these agents, create something amazing, but,
Mhm.
who wouldn't feel a bit lost with all the buzz around things like Autogen and Crew AI?
Yeah, it's true. There's a new framework popping up every other week, it seems like.
Hmm.
And each one promises to be like the solution. It's easy to get swept up in all of that.
Exactly. It's so tempting to just jump right into these complex systems without really even understanding, the foundation. So before we get lost in the sea of frameworks, how about we strip things back, get back to basics?
I am all for that. In this deep dive, we are all about that first principles thinking.
Yeah.
Instead of grabbing the most complicated tool in the shed, let's just understand what we're building, why we're building it, and what we truly need to get the job done.
I like that a lot. That makes a lot of sense. So where do we even begin with that? It sounds like we need like a crash course in AI architecture or something.
Actually, a good place to start is with something you're already familiar with, the concept of data pipelines. You've probably heard of ETL, extract, transform, load. It's kind of the backbone of how we manage data. And for good reason, it's a simple, reliable system that scales.
Okay, I'm with you so far. I use data pipelines all the time in my work. But how does this relate to building an AI agent? They seem pretty different to me.
You'd be surprised. At their core, AI workflows follow a very similar pattern. Input, processing, output. It's the same principle you use in any automation you build, really. You're already thinking like an AI architect without even realizing it.
Wow. That's a great way to look at it. So instead of being intimidated by these complex multi-agent systems, I can start by thinking about my AI agent in terms of this familiar data pipeline structure.
Precisely. And because you're starting with a structure that prioritizes clarity and predictability, the
Mm.
system that you build will be much easier to manage and scale as it grows. You'll avoid that tangled web of code that those overly complex systems can sometimes create.
Yeah, for sure. That already makes those black box AI solutions way less appealing to me now. But you keep saying true AI agent. What's the difference between like a data pipeline or automation and a true AI agent? What makes it true?
That's the key distinction. And it's where things get really interesting. Just because you're connecting steps in a pipeline, that doesn't automatically qualify it as a true AI agent. A true AI agent possesses more, how should I say, specialized capabilities. Imagine, for example, being able to tap into external knowledge bases to augment its intelligence. We call this retrieval augmented generation, or RAGE for short.
So, giving our AI agent access to a vast library of information that it can use to answer questions or complete tasks, that's way beyond a simple chatbot.
Exactly. Think about how you might use function calls to allow your agent to interact with other tools and APIs. Or, even better, how about incorporating some form of learning, even if it's just simple feedback loops to help it improve over time? These are the hallmarks of a truly intelligent agent.
Okay, I'm starting to see the difference. It's like the
Yeah.
difference between a basic task list and a skilled employee who can learn and adapt and take on more responsibility. But how do we actually start building these agents without getting lost in the weeds? Where do we even begin?
Instead of asking, what complex framework can I use? Start by asking, what are the essential components my agent needs to solve this specific problem?
So, designing a custom tool for a specific job. Just as you wouldn't use a sledgehammer to crack a nut, you want the right AI solution for the task at hand. How do we identify those essential components? What should we be thinking about?
Let's break it down. One framework we can draw inspiration from is LangChain, along with OpenAI's approach with their Assistance API. They've done a fantastic job outlining the core elements of an effective AI agent, and I think you'll find them pretty intuitive.
Okay, let's dive in. What's the first component we should consider?
First up is perception. Ask yourself, what data can my agent sense? Now, in the future, we're talking about going multimodal GPT-4's ability to process images and text. But we can start much simpler. Even if we are just working with text, we need to define what that input looks like and how our agent will receive it. This is the foundation of its perception.
Got it. So even if I'm starting with text, being clear about that input is crucial. What comes after perception?
Next, we have the prompt. Think of this as your instruction manual for the agent, almost like an employee handbook. It outlines the agent's role, its tasks, communication style, even its limitations.
So setting clear expectations and giving the agent the guidance it needs to succeed. It's all about communication.
Exactly. And just like any good employee, our agent needs a good memory. That's our third component,
Mm.
memory. We need to think about both short-term memory, like a conversation history to understand context, and long-term memory.
And that long-term memory is where things like databases come in, right? storing information that the agent can access later on.
That's it. It's like upgrading from simple sticky notes to a vast and organized library of knowledge. This is where things get really interesting, and we start to move beyond simple automation.
It really is amazing to think about how much more powerful an AI agent can be when it has access to that kind of organized long-term memory. It's like going from a simple calculator to a supercomputer.
That's a great way to put it. And it's not just about raw storage capacity. We can take this concept of memory even further with something called a knowledge base.
A knowledge base, what's that?
Imagine giving your AI agent access to a curated collection of information that's specific to its tasks or domain of expertise. This could be anything from your company's internal wiki to a database of industry research papers.
So instead of just having general knowledge, our agent would have specialized expertise in a particular area. That's incredible. Isn't that where retrieval augmented generation or array comes in?
You got it. RAG allows us to move beyond the limitations of an AI agent's initial training data. Instead of just paraphrasing what it's already seen, it can tap into this vast external knowledge base to provide truly insightful and relevant responses.
That's a game changer for sure. But we've talked about giving our agent senses with perception, giving it instructions with prompts, and giving it memory and knowledge. What about giving our AI agent the ability to learn and adapt over time? Isn't that a crucial part of any intelligence system?
You're hitting on a critical point. And you're right. The ability to learn is what separates a truly intelligent agent from a sophisticated script. Just like us, AI agents can become more effective as they gain experience.
So how do we actually incorporate learning into our AI agent? Does it require some like super complex coding or algorithms?
It can, but it doesn't have to be that intimidating. We can start with something as simple as providing feedback to the agent. Tell it when its responses are spot on when they need a little tweaking.
So if our agent is summarizing meeting notes, we could give it a thumbs up when it nails the key takeaways and a thumbs down when it misses the mark.
Exactly. Think of it like training a puppy. Positive reinforcement goes a long way. This simple feedback loop helps the agent learn and improve its performance over time.
That makes a lot of sense. But what about those more advanced forms of learning? What if we want our agent to become an expert in a specific field or adapt to a constantly changing knowledge base?
That's where techniques like fine-tuning come in. It's like taking your AI agent back to school for specialized training. You can further train it on a data set of examples specific to your needs. This could be anything from refining its writing style to deepening its understanding of a specific industry jargon.
So we're basically customizing its education to mold it into the perfect AI assistant for the job. This is all so fascinating, but before we get too carried away with all these amazing possibilities, shouldn't we talk about how to actually build these things?
You're right. We've covered a lot of ground conceptually. But the real magic happens when we start putting these ideas into practice.
So for our listeners who are ready to roll up their sleeves and start building, where do we even begin?
I highly recommend checking out OpenAI's Assistance API. They've made it surprisingly accessible, even for developers who are new to the world of AI. They've done a great job abstracting away a lot of the complexity, allowing you to focus on building the core logic of your agent.
Their documentation is excellent too, which is always a plus.
Absolutely. And another great thing about OpenAI's Assistance API is that it integrates seamlessly with a wide range of other tools and services, making it incredibly versatile for building custom solutions.
Okay, so OpenAI's Assistance API is our starting point. But we're not just going to throw code at the wall and see what sticks, right? We need a plan.
Exactly. And that's where our understanding of the core components comes in. Let's revisit those components and talk about how to implement them using OpenAI's tools.
Sounds like a plan. So where do we start?
Let's go back to the beginning with perception. If you're working with text data, which is a great place to start, think about how you can prepare that data for your agent. This might involve something called tokenization.
Tokenization, that sounds a bit technical. What exactly is that?
It's simpler than it sounds. Tokenization is just breaking down text into individual words or phrases, which makes it easier for our AI agent to understand and process.
So we're essentially pre-digesting the information for our agent to make its job a little easier.
Exactly. And along with tokenization, we might also use something called named entity recognition. This involves identifying and classifying key elements in the text, like people, places, and organizations. It's like highlighting the important stuff for our AI agent.
Okay, so we're pre-processing the text data to make it easier for our agent to digest. What about the prompt? Any tips on crafting effective prompts for our AI agents?
Clarity is key. Think about your prompt as a set of instructions for a human assistant. Be clear, concise, and avoid using any technical jargon that your agent might not understand. Remember, we want to make its job as easy as possible.
It's like when you call a customer service line and you get stuck in an endless loop of automated menus. Keep it simple.
Exactly. And remember, context is crucial. Provide enough background information so your agent understands the task at hand and can make informed decisions. Don't be afraid to use examples either.
So instead of just saying write a blog post about AI agents, I might say, I need a blog post about AI agents that focuses on the benefits of building custom agents using OpenAI's Assistance API. The target audience is software developers who are new to AI agents.
Now you're thinking like a prompt engineer. That level of detail will give your agent a much better chance of delivering what you're looking for.
This is great. I'm already starting to see how these pieces fit together. We've covered perception and prompts, but we've still got a lot to unpack. What about memory, knowledge bases, those amazing function calls? We've barely scratched the surface. It's funny to think that giving an AI agent a good memory is even a thing, but it makes sense. That's how it learns and builds context, right?
Absolutely.
Uh,
And remember how we talked about short-term and long-term memory? Well, with OpenAI's tools, that long-term memory often takes the form of vector databases.
Vector databases. Okay, that's a new one for me. What are those all about?
Imagine a database that can store not just text, but code, images, audio, even sensor data, and make it easily searchable by our AI agent. It's like giving it a library card to a library that holds almost any type of information imaginable.
So instead of just remembering that I asked about a specific product, an AI agent using a vector database could recall my entire purchase history, my preferences, maybe even my sentiment from previous interactions. That's amazing.
Exactly. And when you combine that powerful long-term memory with a well-crafted knowledge base, you can really start to see some amazing results.
We touched on knowledge bases earlier, but as a refresher, how would those work in practice?
Think of it like this. We can connect our AI agent to relevant external sources of information, like internal documents, industry reports, or even public data sets. This gives it access to a vast pool of specialized knowledge that goes way beyond its initial training data.
So our AI agent could essentially become an expert in any field we need it to be. It could be a marketing guru one minute and a software developer the next. That's incredible.
It's all about providing the right information at the right time. And that brings us back to retrieval augmented generation, or IR.
Right. RI essentially gives our AI agent the ability to pull in relevant information from its knowledge base in real time, just like a human expert would.
Exactly. And when combined with those powerful memory capabilities, it allows AI agents to provide much richer and more insightful responses. It's no longer just regurgitating what it's been trained on. It can actually synthesize information from a variety of sources to answer complex questions and solve problems.
This is all mind-blowing stuff. But we've talked a lot about giving our AI agent information. What about giving it the ability to act on that information? That's where those function calls come into play, right?
You're right, just knowing things isn't enough. We want our AI agents to be able to DO things, to interact with the world around them. That's where function calls become essential.
Okay, so walk me through this. How would we actually use function calls to give our AI agent some real-world powers?
Think of it like this. We can connect our AI agent to external APIs and tools, essentially giving it hands to interact with the digital world. Wanted to schedule a meeting? Connect it to your calendar API. Needed to pull in some data from a website? Connected to a web scraping tool. The possibilities are practically endless.
So we're essentially turning our AI agent from a passive observer into an active participant in our digital lives. That's both amazing and a bit intimidating.
You hit the nail on the head. We have to remember that with great power comes great responsibility. As we give AI agents more autonomy, we need to be mindful of security and always have proper oversight.
That's a really important point. We've covered so much ground today, from data pipelines to vector databases, knowledge bases, and those all-powerful function calls. It's a lot to take in. If you could leave our listeners with one key takeaway, what would it be?
I would say, don't let the complexity of AI overwhelm you. Start with a clear understanding of what you want to achieve. Break down your problem into those essential components we discussed, and then use those components as building blocks to construct your solution.
Start simple, build iteratively, and don't be afraid to experiment. That's great advice. And with tools like OpenAI's Assistance API, it's becoming easier than ever to turn those AI dreams into reality. Well, that's about all the time we have for today's deep dive into building smarter AI agents. We hope you found it insightful and empowering. Remember, the future of AI is in your hands, so go out there and build something amazing.